acids and bases. Theories of acids and bases. There are heaviest theory of acid and base. There is a Lowry Bronsted theory of acid and base. There is a Lewis theory of acid and base. These three are the some important theories of acids and base. Besides this, also we have Ingold concept of acid and base. We have Oceanography concept of acid and base theory. Okay, so many are there, but these three are the most important theories about acids and bases. So under this theory, some substances are coming as acid and base, but not all. Similarly, some other substances, acidic or basic behavior, are coming under this theory, and again some are coming under this theory. Okay? First of all, we discuss about your R and S. So what says it? According to Arrhenius, a substance is considered to be an acid if it furnishes H plus ion when dissolved in water or in aqueous solution, while a base is a substance which can furnish OH minus ion in aqueous solution. Okay? An acid is a substance which can furnish H plus ion in aqueous solution. Okay? A base is a substance which can furnish OH minus ion in aqueous solution. Okay. So what is an acid? An acid is substance which can furnish a H plus ion in aqueous solution. So if I write, suppose HCl plus aqueous means water. Okay, you give water H plus aqueous plus Cl minus aqueous. Okay. HCl aqueous H plus aqueous plus Cl minus aqueous. Okay. HCl plus aqueous, you have your H plus aqueous plus Cl minus aqueous. Okay. HNO3 aqueous means water. H plus aqueous plus NO3 minus aqueous. Okay. Similarly, H2SO4 plus aqueous 2H plus aqueous plus SO4 2 minus aqueous. So here you see, in this case HCl, this HCl when dissolved in water, that means in aqueous solution, it is furnishing H plus ion and Cl minus ion. Okay. Similarly, HNO3 is giving water of H plus ion and NO3 minus ion. Similarly, H2SO4 is giving what? 2H plus SO4 2 minus ion. Now, because of these substances HCl, HNO3, H2SO4 are giving H plus ions in aqueous solution, so these HCl, HNO3, H2SO4 are considered as acids. Similarly, if I take NaOH, aqueous, you got Na plus aqueous plus OH minus. So here you see NaOH is giving water OH minus ion. So because NaOH is giving OH minus ion, so NaOH is a base. Okay, I take NH4OH plus aqueous, give what? NH4 plus aqueous plus OH minus aqueous. So here NH4OH is giving OH minus ion, so NH4OH is a base. Okay, KOH plus aqueous give what? K plus aqueous plus OH minus aqueous. So NaOH, NH4OH, KOH are substances which can give OH minus ion when dissolved in water. So these are considered as base according to RNS. So here HCl, HNO3, H2SO4 are the arrhenius acids because they are giving H plus ion in aqueous solution. Similarly, NH4, NaOH, NH4OH, KOH are the arrhenius bases because they are giving OH minus ion in aqueous solution. Okay, and also according to this RNS theory, the neutralization between an acid and a base with the key reaction between H plus of acid and OH minus of base. So neutralization between acid and the base is the key reaction between H plus of the acid and OH minus of the base. So if you consider here, if I react an acid and the base, I will get what? You will see I take HCl, give water, H plus Cl minus, NaOH, gives water, Na plus OH minus. So this is H plus and OH minus. You give water, NaCl plus H2O. So here H plus of the acid and OH minus of the base are reacting to give water, and this is the key reaction of the neutralization of the acid and base. Okay, so when the acid and base are reacting, neutralization reaction takes place. Okay, where salt and water are formed. And here the reaction between the H plus and OH minus ion is the key reaction. So for this neutralization. Okay. So this is about how the R-H theory. But one thing you can notice here, when this acid is dissolved in water, it is giving H plus ion according to this theory. But we know H plus is a proton. See, when I am talking about the hydrogen atom, okay, we have what? H1. So in this H11, we have one electron and one proton. Now H minus one electron is what? H plus. That means here the number of electron is 0, proton is what? 1. So H plus is nothing but a what? But a proton. And this proton is unstable. It cannot exist independently. Okay. So as soon as the HCl is dissolved in water, it is giving the proton. Now this proton is unstable. So this proton is combining with water. So H plus we have H2O. So this proton accepts a pair of electron from this what? From this H2O. We have here I can write HOH. So here we have two lone pair of electrons. So this proton being unstable, it attacks what? This one and giving what? H3O plus. That means when the acid is dissolved in water, that can furnish hydronium ion. This is called what? This is called what? Hydronium ion. So instead of talking about the H plus ion, we can say what? We say hydronium ion. So this is one of the limitations of this R-H theory. Number 1. Number 2. So limitations, what you can say that the H plus is a proton which is unstable one. So this H plus can accept a pair of electron from water and exist as what? Hydronium ion. Okay. Limitations. Okay. So H plus a proton can't exist independently and takes a pair of electron from water, exist as a hydronium atom. Which is what? Hydronium atom. Okay. And the second thing is what? In R-H theory, acids are substances which can furnish H plus ion when dissolved in water. That means this concept is limited to aqueous medium only. Okay. So if a substance is not dissolved in water, then we cannot define that whether it is acid or base. Okay, so limited to aqueous medium only. Okay, so these are the limitations of R immersion theory. Okay, so in order to overcome these difficulties, these limitations, okay, so another theory is called part of the Lowry-Bronsted theory of acids and bases. Number 2, Lowry-Bronsted theory. So what acid is the Lowry-Bronsted theory? According to Lowry-Bronsted theory, an acid is a substance which can donate a proton, whereas a base is a substance which can accept a proton. Here, there is no limitation of aqueous medium. We are not concerned about whether the substance is dissolved in water or not. That's not the matter. If the substance can donate a proton, that's an acid, and if a substance accepts a proton, that's a base. Okay, so substance which can donate a proton, okay, is acid. Why? Substance which can accept a proton is a base. Okay, so if I take suppose HCl give what? H plus Cl minus. If I take HNO3 give what? H plus NO3 minus. Okay. H2SO4 2H plus SO4 2 minus. Okay. So in this cases, these substances are donating a proton. Here the H plus is considered as what? As a proton. This is a proton, it's 2 protons, okay? And similarly, if I take NH3, these are what? Acids. NH3 plus H plus is what? NH4 plus, okay? So you see NH3 ammonia can accept a proton. So it's a what? It's a base. It's what? It's proton. H2O plus H plus. H3O plus. Okay? So it's what? Base. What? Base. OH minus plus H plus H2O. Okay, so OH minus here can accept a proton. It's a what? It's a base. Okay. So though these are substances, HCl, HNO3, H2SO4 can furnish or can give a proton. So these are what? Acids. And NH3, H2O, OH minus are substances which can accept a proton. So these are what? Bases. Now see, if I write HCl plus aqueous will get what? H plus aqueous plus Cl minus aqueous. So HCl in aqueous medium can give what? Can give H plus ion, so it is an acid. Similarly, HCl can give a proton here, H plus proton, so it is also acid. But here, this acid is what here? I can say arrhenius acid. And this is what here? This is what here? Bronsted acid. So all kind of arrhenius acids are giving H plus, and all kind of Bronsted acids are also giving H plus as a proton. So what you can say? All the arrhenius acids are the Bronsted acids. But if I consider here the NaOH, will give what? Aqueous, NaOH, aqueous will give what? Na plus OH minus. It's what? It's your arrhenius base. It's what? Your arrhenius base. But here you see, NH3 can accept a proton, it's a base. H2O can accept a proton, it's a base equal to Bronsted. That means see, all arrhenius bases are not Bronsted bases. Okay? So because in arrhenius acid we are having H plus ion, and also in Bronsted acid we are having proton as H plus ion. So all arrhenius acids are Bronsted acids, but all arrhenius bases are not Bronsted bases. Okay? So what you can say? Write note here. Okay? What you can say? All arrhenius acids are Bronsted acids, but all arrhenius bases are not Bronsted bases. And this is important point too, we have to remember. Okay? All arrhenius acids are Bronsted acids, but all arrhenius bases are not Bronsted bases. Okay? Now see, in this Bronsted bases, low Bronsted theory, we are having the acids which can donate a proton and bases which can accept a proton. So the difference between the acid and the base is nothing but a proton only. Here you see, if I write HCl, okay, it can give what? H plus Cl minus. And this is what? Acid. And this acid can donate a proton. HCl can donate a proton, so it's an acid. Now, when this HCl is giving the proton, the residual part Cl minus. Now, this Cl minus plus H plus can be what? Can be what? HCl. That means after giving the proton, the residual part is having a tendency again to accept the proton. So the residual part will be considered as a what? As a base. HCl giving the H plus proton, remaining the what? Shear mass. Now the remaining can again take a proton to give your HCl. So here this part is also called what? A base, and this base is only a difference of H plus from this acid. So we can say this base is the conjugate base of this acid. Okay. So it's what conjugate base. Okay. And this is two things. This is your HCl and this is magnesium. You can say what? The conjugate acid base pair. Conjugate acid base pair. Okay. So the set of acid and base which differ by a proton only are called what? Conjugate acid base pair. Okay. Let's see. Okay, so if I write here, of course, if I write NH3 plus HCl. See, NH3 is a what? It's a base. It can accept the proton, convert into what? NH4 plus, okay, plus what? Shear minus. So here you see NH3 is the base. It accepts the proton from the H, okay, because what? NH4 plus. So here NH3 and NH4 plus. These two are differ by a proton only. This I can say the base 1. Base 1. Okay. So this will be what? Acid 2. Acid 1. Okay. So NH3 is the base. Can accept a proton, convert into what? NH4 plus. Now again, this NH4 plus can donate a proton, convert into what? NH3. So these two are differing by a proton only. Okay, and this is if I consider this as a base, then this will be what? The conjugate acid of this base. Okay. Similarly, now this HCl. So this NH3 is receiving the proton from this HCl. So this is what? Acid. Acid 2. And this HCl, when giving the H plus to this ammonia, converting what? Cl minus. So these two are again what? HCl and Cl minus. So these two are again differ by a proton only. So this is what? Base 2. So base 1, acid 1 are the conjugate acid base, and acid 2, base 2 are the conjugate acid base. So what is the write? The idea acid will give you H plus plus conjugate base, okay, and the base plus H plus are the conjugate acid. Okay, so we can say acids are the proton donors, bases are the proton acceptors. Okay, so whenever we are having acid, you just remove a H plus ion, we will get what? The conjugate base. Whenever we are having a base, you add a proton, we will get what? The conjugate acid. Okay. Now let us see. Right here. As see, sometimes we are having the substances which can accept a proton and also can donate a proton. And these kind of substances are called what? The conjugate. They are called what? The amphoteric substances. Okay. So a substance which can donate a proton and also can accept a proton is called what? Amphoteric substance. For example, you see, if I take H2O, H2O can give what? H plus OH minus. Here H2 is what? H2 can donate a proton, acid. Similarly, H2O plus H plus, you what? H3O. Here H2O accept the proton. It's a what? It's a base. So H2O can donate a proton, also can accept a proton. So it's what? It's a amphoteric nature. Yeah. Now see, let us see how to find out the conjugate acid-base pairing of the substances. Question. Find out the conjugate base HCl HSO4 minus H2O H2O H2SO4 SCO3 minus. Okay. Let's see. Find out the conjugate base. Means these are what? Acids, and we know acids is having a tendency to donate a proton. So from the acid, if I remove the H also, I will get what? The conjugate base. Okay. So let's see. HCl. You get what? H plus C minus. So this is what? Conjugate base. Conjugate base. This is what? Acid. So acid giving the proton and gives part of the conjugate base. Similarly, HSO4 minus. H plus SO4 2 minus is the conjugate base. H2O H plus OH minus ion is the conjugate base. HNO3 H plus NO3 minus is the conjugate base. Okay. So this is these are the conjugate bases. Meaning H2SO4 2H plus H2SO4, H plus HSO4 minus. Okay, so H2SO4, okay, with the acid giving the proton. Okay, so the conjugate base is what? HSO4 minus. Okay, HCO3 minus, H plus CO3 2 minus. Okay, so HCO3 is an acid giving the proton and remaining part of the CO3 2 minus. So here Cl minus is the conjugate base of HCl, SO4 2 minus is the conjugate base of HSO4 minus, OH minus is the conjugate base of H2O, NO3 minus is the conjugate base of NO3, HS4 minus is the conjugate base of H2SO4, and CO3 minus is the conjugate base of HCO3 minus. And here you see the difference is only a proton. Clear? Similarly, also we can write the conjugate acid. Okay. Find out the conjugate acid. Okay. Okay, so find out the conjugate acid. See, that means these are the bases. Okay, and the base is the substance which can accept a proton. So to get the conjugate acid, we can add a proton to the base. Okay, so what can write now? H2O plus H plus. You will give what? H3O plus. So this is what conjugate acid. Okay. Similarly, NH3 plus H plus will give what? NH4 plus. Okay. OH minus plus H plus. What here? H2O. CO3 2 minus plus H plus. What is your? HCO3 minus HSO4 2 minus plus H plus. What is your? H2SO4 F minus plus H plus. What is your? HF. Okay. So these are the conjugate acids. So H3O plus is the conjugate acid of H2O. NH4 plus is the conjugate acid of NH3. H2O is the conjugate acid of OH and so on. And here you can see these two are differ only by a proton. Okay. So this theory, though overcome the concept, the limitations of the aqueous medium, still so many substances are there which we cannot define whether acid or base under this theory. So we are having many kind of acidic oxides, basic oxides are there, and they are not coming under this theory. And also we are having so many electron deficient species, so which are acidic in nature, but that we cannot define under this theory. So another theory again came into play, that is called Lewis theory of acids and bases. Okay. Lewis theory. So what is Lewis theory? According to Lewis theory, an acid is a substance which can accept a pair of electrons, whereas base are substances which can donate a pair of electrons. Okay, that means see, an acid is an electron pair acceptor, while a base is an electron pair donor. Okay. Acids are substances which can accept one pair of electrons base are substances which can donate pair of electron. Okay, so let us see electron deficient species. For example, you see if I take AlCl3. AlCl3, you see here Al, Cl, Cl, Cl. That means see 6 electrons are there around this aluminum atom. And we know in order to have the stable electronic configuration, the atom must acquire 8 electrons in its outermost orbit. And here we have only 6. So another 2 electrons it can accept. That means see, it is electron deficient and can accept a pair of electron. So AlCl3 is an acid according to Lewis theory. Okay, similarly I can take example of BF3. Okay, so AlCl3, BF3, okay, like electron deficient species are acidic in nature. Okay, you can say Lewis acids. Okay, electron efficient species. See, write NH3, ammonia. Here see NH. You see this ammonia, this nitrogen atom having 2, 4, 6, 8 electrons are there, and one electron pair is there as a lone pair. So this lone pair of electrons, so this nitrogen atom can donate. So it's a what? It's a Lewis base. Okay. Okay. So ammonia, I can say R1. Here you see, in this oxygen atom, we are having what? We are having this lone pair of electrons. So, and this electron pair it can donate. So it's a what? It's a Lewis base. Okay. RNS2 amines. Okay, so ammonia, alcohol, amines are the Lewis bases. Okay, similarly the positive ions. Okay, that means electron deficient, they can accept electron pair. So Lewis acids. Positive ions Fe+2. Okay, like okay. Negative ions like OH minus, Cl minus. Okay, here what? Lewis bases. Here what? Lewis acids. Okay. In addition to this, also we are having the compounds containing multiple bonds of different electronegativity, like carbon dioxide is also a what? Lewis acid. Okay. Okay. Molecules having multiple bonds. Okay. Between atoms of different electronegativity, like carbon dioxide, but Lewis acid. Okay. Also molecules like SiF42, ZnCl2, also what? The Lewis acid. Okay. So all total what you can say, Lewis acids are the electron acceptor, Lewis bases are the electron donor. And the neutralization between acid and base is the formation of coordinate bond between the acid and the base. For example, see, if I take NH3 is what? The Lewis base. And I have H plus is what? Lewis acid. Okay. So what you can say here? N H H H H plus. So this is called coordinate bond. Okay. So the acid and base are forming coordinate bond. The Lewis acid and Lewis base undergo neutralizations by forming the coordinate bond. NH4 plus is here. NH3 plus H plus is base is C, giving what? NH4 plus. Here it is the coordinate bond. Okay. So these are all about for the theories of acids and bases. Okay. So in the next class we will discuss about the ionization of water or ionic product of water and pH of solution. Okay.